The use of chemicals for sterilization involves killing microorganisms through the use of chemicals. These include ethylene oxide, vaporized hydrogen peroxide, and nitrogen dioxide. Ethylene oxide gas sterilization is a sterilization agent used mostly in medical devices. It alkylates microorganism DNA, RNA, and protein. There are several benefits in the use of ethylene oxide sterilization. It is an effective and reliable process. It is compatible with single-use medical devices and some drugs that are sensitive to heat sterilization and moisture. For example, it avoids heat and radiolytic stress associated with steam or gamma radiation. Products can be sterilized in their final packaging of sealed films and cartons. Ethylene oxide can be neutralized with water. But unfortunately, all that glitters is not gold, and there are some disadvantages too. Ethylene oxide is a colorless and odorless gas at 430 ppm. You need to be careful with safety precautions. It is flammable and explosive. It has potential hazards with patients and staff. Exposure can cause eye pain and sore throat, difficult breathing and blurred vision, dizziness, nausea, headache, convulsions, blisters, and can result in vomiting and coughing. The sterilization process requires special measures and care for the protection of workers and patients. It requires a designated area with sophisticated technology and equipment. Employee exposure is limited to 1 part of ethylene oxide per million parts of air, measured as an 8-hour time-weighted average. It has relatively long process times at 40 degrees to 60 degrees Celsius, from hours to days of sterilization. Ethylene oxide gas has some limitation of penetration. It is practical if the ethylene oxide can penetrate easily into the material to sterilize, for example, when the material is spread thin. Otherwise, it will not occur for bulk volumes. This is why it is mostly used for consumables. Ethylene oxide is a commonly used method for sterilizing medical devices, as it is highly effective and does not cause damage to the device during the process. This method is particularly well suited for devices made from certain materials such as polymers, metals, or glass, or those with multiple layers of packaging or hard-to-reach areas such as catheters. Vaporized hydrogen peroxide is an emerging technology for sterilization. It is a low-temperature process useful for decontaminating surfaces of non-heat resistant medical devices. It requires less time than sterilization with ethylene oxide. Once the sterilization cycle has completed, the vapor is vacuumed from the chamber and converted to water and oxygen, so no toxic residues remain. It is a non-toxic, environmental, and safe solution. Nitrogen dioxide sterilization uses a combination of nitrogen oxides and ozone to sterilize products in a closed chamber. This method is based on the ability of nitrogen oxides and ozone to kill microorganisms by disrupting their cell membranes. It destroys nucleic acids and disrupts their DNA. Let's look at the benefits. Nitrogen dioxide is a gas at room temperature. Its boiling point is 21 degrees Celsius. That means it is easy to use both in vapor and liquid form. The concentrations used in sterilization are typically less than 1% of the saturated vapor pressure. The sterilization process is efficient because nitrogen dioxide is highly sterilant, capable of inactivating a wide range of microorganisms, including bacteria, viruses, and spores. It is safe because it is non-toxic. It poses minimal health risks to operators and patients. It leaves minimal residue, reducing the need for extensive cleaning. Residues are non-toxic. It is compatible with a wide range of materials, including plastics, metals, and glass. It is an alternative method of ethylene oxide that can reduce costs and turnaround time. It has a cycle time of 2 to 4 hours at a temperature of 10 to 30 degrees Celsius. It is a cost-effective option as it does not require specialized equipment or facilities. Heating is not required, and it is effective in the sterilization of pre-filled syringes, drug device combination products, and custom implants. There are other chemicals that are used for sterilization or even disinfection, like glutaraldehyde and formaldehyde, peracetic acid, ozone, bleach, and chlorine dioxide. Formaldehyde, glutaraldehyde, and chlorine dioxide are gases and are commonly used to sterilize clean rooms. It is essential to ensure that the sterilizants are compatible with the device being sterilized. The selection of an appropriate sterilization method requires a thorough understanding of the medical device, the drug substance, as well as the final product characteristics. And that's all for another Scilife Academy session. Thank you for attending this course on filtration and chemical sterilization. I hope you found it useful and that you have learned what you expected. See you in other courses at the Academy to continue your educational journey with Scilife.